All right, let's get started for today. So over here on the left, I have my my console, my idle, right? So that's going to be the place where I can enter stuff right away, and it gives me back, it's my fancy calculator. And over here, I have my scripts, my script that I'm working on, just so you see what I'm working on, so you see what I'm doing. So just to remind you, right? So we have this. We go File, Save. I want to save this in my Python scripts folder. Okay, so now if I want to run it, I type run, I do run, then run module. And we see our result over here. Okay, so today we're going to be talking about if statements. So far, we've done stuff like set variables, x equals 2, and then we can do math with the variable. So we say y equals 4 times x minus 5.5. Then, we can print out x. But all of this, it just goes straight through. First it does this, then it does this, then it does this, and then it does it. So it's just going to do every single statement that I write, all the way to the bottom. And that's fine, but sometimes I only want to write a statement if something is true or not. So sometimes there's statements that I only want to do sometimes, and that's what we're going to look at today, where there's statements that you sometimes want to do. So for example, if I want to check if a number is positive, let's get a number. Let's read in a number. So let's see. Let's call it n for number equals int input. And remember, this is going to get an integer from when I run it. Enter a number. Okay, let me run this. Make sure that works. Run module. And I see over here it printed out enter a number, and I click over here. It's waiting. I hit a 5. Oops, I didn't enter a number. I enter a 5. Okay, so that works. That 5 got saved into this value n here. So now what I can do is I can say if n is bigger than 0. Okay, so this right here, the n bigger than 0, is what we call a Boolean expression, meaning that it's a statement that's either true or false. So it's either true or false that n is bigger than 0. If n is negative, right, that's false. Or if n is positive, it's true. So if this is true, if n is bigger than 0, then what? Let's print n, the value you entered is positive. Okay, let's try this. So notice the colon, right? That's important. If you don't have that, it's going to complain. And notice also that it's tabbed. Okay, if you do the colon, it should do this automatically. So if n is bigger than 0, it does everything that's indented. So I run this. So it's waiting. It printed this out, and it's waiting to get a number to store in n. Okay, so it's waiting. Let's put a number in. Let's put 5. And we see that it says the value you entered is positive. Cool. Let's try that again, but let's put a negative number in and see what happens. So if I put negative 5 in, nothing happens. And that's what we want, right? So it got here, it checked, is n bigger than 0? Well, we put in negative 5, so no, it's not. This was false, so we just skip the next line, skip the indented stuff, and go down here. So if I was to put print done down here, notice that this is not indented. So if this is false, it just skips down to where it's not indented anymore. So if I run this and I put in negative 5, it's going to check Is it bigger than 0? No. So I skip the indented stuff, and I'm just going to print done. So I do this, and that's what we see. If I do it again, but I put in a positive number, right? This is true, so it does this thing. It does this line, and then it keeps going. Right? Once it gets to the end, it keeps going, and then it prints done. So we put in 5, and there we go. This allows me to sometimes execute a line depending on what I'm doing. Now, sometimes there's more than one option, right? Here we can either print this or not. But what if we also wanted to check if it's negative or if it's 0? So what we can do is if n is equal to, this is important right here. Notice that the equals is equals equals. That means that we're comparing if two numbers are the same. So is n the same value as 0? If I just do this, this means that n equals 0. So n is going to save the value 0. We don't want that. We want n equals 0. So now this is going to say, is this true? If it's not, then we go down to the next one and check if this is true. Right? So if n is not positive, we go down and check, is it 0? If it is, print the number was 0. Okay, so now I can enter a positive number and watch what happens. Just the same stuff as before, right? It got the number 5. It said, is this true? It is. So it printed this out. And then it skips down to the end and prints out done. If I run it again and put in 0, this will be false, so it skips it. This one will be true, right? N is the same as 0. So it's going to print the number was 0. And I could do that again. Elif means else if. Otherwise, if n is less than 0, print number was negative. So now if I put in a negative number, right, it's not positive, it's not 0, but it is negative, or it is less than 0. So this is what's going to happen. So if I put in a negative number, we see the number was negative. And then it skips down to the end. And I can have as many cases as I need. Hopefully you don't have too many, but there's no limit to really how many you can do. Now we have something here that's a little bit redundant. If n is bigger than 0, then it's positive. If it's equal to 0, then it's negative. But if it's not positive and it's not 0, we know that it has to be negative. It doesn't have to, we don't have to check if it's less than 0. We know that's going to be the case. So there's one more thing that we can do. We can do else. And what this means is check if this is true. If it's not, do this. If this is not true, then whatever else happens, do this one. Okay, so here there's nothing to check. It's just if it got this far, it's going to do this. And for our case here, that's the same as what we want. Right, if I put in -8, we got the same answer. Okay, so if this is true, do this. Otherwise, check if this one is true. If so, do this. Otherwise, do this. Right, so if none of the other ones were true, do this one. So it's kind of like the default case. Okay, so here's another example. Let's number is even or odd. Here we are check if number is positive. Okay, so what does it mean for a number to be even? So this is kind of important. It means that the remainder, when I divide it by 2, is 0. So if I take 8 and I divide it by 2, I can divide it with a remainder of 0. And in Python, we can get the remainder very easily. So the remainder, I can do this by doing, let's do 8%. So the percent means the remainder when I divide 8 by 2. So if you remember back to 3rd, 4th grade, right, the remainder when I divide 8 by 2 is going to be 1. I can do this over here. So I do 8 remainder 2, or 8 mod 2. The remainder should be 0. If I take 8 and I divide it by 3, the remainder should be 2. And if I take 8 and divide it by 5, I should have a remainder of 3, which I do. So this is how I can get the remainder. So I can check if a number is even if the remainder, when I divide it by 2, is 0. So if the remainder, when I divide by 2, right, this is the remainder, is equal to 0. Right, so actually, I can do this here. 10% 2. Right, so this is the remainder. And I can just check if the remainder is equal to 0, then do what? Let's just print n is even. But if it's not even, we know right away that it's going to be false. I can say if it's not even, otherwise, so if it's not even, print n is odd. So here it's going to check if this is true. If it's not true, then we have our default case. We're just going to print n is odd, because we know if it's not even, then it has to be odd. Okay, let's do a little bit more interesting of an example. So let's write a program that will check a letter let's see, if the user enters A, E, I, or U, then your program should display a message indicating that the entered letter is a vowel. If the user enters a Y, then your program should display a message indicating that it is sometimes a vowel. In all other cases, your program should display a message that the letter is a consonant. Okay, so the first thing, let's just read the question. The first thing is write a program that reads in a letter from the user. So let's do that first. That's the very first thing I should do before I can go much further. So let's go, actually, let me start this in a new file. So here I am in a new file. So I'm going to say letter. Let's get the letter from the user. So this is going to be letter equals. Now I don't want an integer, right? I don't want a number. I just want the letters. Input, right? So I'm going to say input, and then whatever I want it to print out before someone starts typing. Right, so again, I'll save this and run it. What exercise number was this? Doesn't matter. Okay, so if I run this, it says enter a letter, I enter an A. Okay, it works. Great. Let's keep going. So it says if the user enters A, E, I, O, or U, then your program should display a message indicating that the entered letter is a vowel. So let's start with that. If the letter is the same as, is equal to A, then do what? We can print vowel. If it's not an A, then let's check something else. If it's not an A, then let's check if it's an E. If it's an E, what do? Well, if it's an E, we print the vowel. Okay, what if it's not an A and it's not an E? Then let's check elif letter is the same as an I, colon. If it is, we print a vowel. Okay, if it's not one of those, then we can check again, elif letter equals O. If that's the case, we print vowel still. One more case, elif letter equals U, print vowel. Okay. Now, so we did that. So we can actually check this. Actually, I should have checked it a long time ago. I should always check. As soon as I try something new, I should run it to see if that works. So if I put in an A, it says vowel. And if I run it again and I don't put in, say I do like a T, good, nothing happens. I don't want anything to happen for that yet. And if I put in, let's just try an I, it works. Cool. So now let's keep going. So it says if the user enters A, E, I, or U, then your program should display a message indicating that the entered letter is a vowel. Check. If the user enters a Y, so elif letter equals Y, so if it's a Y, what do? Then your program should display a message indicating that it is sometimes a vowel. Just copy that. Okay, I can run that real quick. So I'm over here. If I enter a Y, we get sometimes a vowel. Cool. And then it says, so that's check. That's checked off. In all other cases, your program should display a message that the letter is a consonant. Meaning that if none of these are true, else, otherwise, print consonant. Let's test this out. If I do an A, it works. If I do an E, that works. What if I do a J? So ideally, it should print out the consonant because it's not an A, it's not an E, I, O, or U, and it's not a J, so it gets down here, and then it's just going to print consonant. So let's check that, and that worked. Let me do one more test. Let's print an R. That should also be a consonant, and it is. Okay, so this right here was a lot of typing, and a lot of it was very, very much the same, right? We're doing the same thing in all of these cases. To save ourselves some typing, what I can do is I can say if letter equals A or letter equals E or letter equals I, and actually I can keep going on this, or letter equals O or letter equals U. Then what do we want to do? We want to print val. So if this works, then we don't need to do any of this stuff right here. Let's see, can I put this in one line? Will it fit? Okay, it doesn't really fit. So I'm going to split it onto 2 lines. Okay, so just imagine this as one long line. If the letter is A, or if it's E, or if it's I, or if it's U, or if it's O or U, then we print val. If none of those are true, then we go down here to the next one. Check if it's a Y. If it's a Y, we print sometimes a val. And if it's neither of those, then we know it's a consonant. Okay, next example. Okay, so it says write a program that reads in the name of a month from a user, then print the number of days in that month. So let's get the input first. So let's call it month. That's just going to be a string, right? So it's just going to be letters, the letters of the month. So it's going to be input, enter a month. And I'm just going to abbreviate for this question. I'm going to abbreviate each of the months. So it's going to be Jan, Feb, Mar, April, May, June, July, August, September, November, December. Okay, this is just for my notes or whatever, so I can check later. Okay, so consistent. So if month is equal to Jan, right, for January, let's print how many days are there in January? There's 31. Okay, if it's not in January, elif month equals February. Let's print 28. If it's not one of those, we keep going. March. Actually, I'm going to go ahead and copy and paste this. Let's see, print 31. So I'm going to copy and paste this a couple times and then go back and fix each of them. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So here, if it's January, February, March, April, May, June, July, August, September, October, November, and if it's not one of those, in December, and if it's not one of those, right, else, right, if it's not one of those ones above already, you will print not a month. Okay, so January has 31, February has 28, March has 31, April has 30, May 31, June 30, July, August has 31, September has 30, October 31, 31, 30, 31. Okay, and this should This should work. Let's go months ex. Okay, so it says enter a month. I actually want there to be a space right there. Let's see, let's put a colon and a space. Okay, so it says enter a month. Let's put in January. We get 31. Great. Let's run this again. Let's put in October. We get 31. Let's do one more. Let's put in something random. It says not a month. Great. Actually, there's one more that I want to do. Let's put in capital OCT. And it says that's not a month. Because when we're comparing month with October right here, OCT, it needs to be exactly the same, right? So the capital here makes a difference. So in our simple program, it's not going to recognize capital letters. It's just going to recognize exactly lowercase OCT. And we could also simplify this just like we did in the last one, where we use an OR. So all of the ones with 31, let's just put those in one if statement. So if it's January, or if it's March, or May, notice that each time I have to do if month equals May, or month equals August. Did I do August? No, I haven't done July yet. Or July. Let's break that. Or August, or if month equals August. So what I can't do is say if month equals January or March or May or June. That doesn't work. Okay, I need to do if month equals this. And do this, and then finally we have December. So that's all of the days with 31 days. So in either any of those cases, I want to print 31. Okay, so I don't need those anymore. I can get rid of those cases. Okay, so now let's do the ones with 30 days. So we can have April or June or month equals, oops, I almost made the mistake. I almost said month equals September, but remember I need equals. Or month equals November. In any of those cases, we're going to print 30. All right, so if it's one of these, we print 31. If it's February, we print 28. If it's one of these, we print 30. Otherwise, right, otherwise, it's not a month. Oops, I have a problem. It doesn't like me putting this on a new line. Is that right? Okay, fine. So it doesn't like this on a new line. So I'm going to put this all on one line. Okay, so if I go full screen, you should be able to see that. And then here, same thing, I'll put this on full screen. And there we go. Or actually, something else I could do, if I put this as if m equals input. So now I'm comparing m with each of these. This will make it fit better, but this doesn't really matter, right? The other one would have been just fine. Right, so now my input went into the variable m, so I'm just renaming all of the m's to this. Okay, it does the same thing, right? So we're checking if is this variable, is it January, is it March, is it May, is it one of these? If not, check if it's February. If not, check if it's one of these. If not, do this. Okay, next example. This is my last example. No, wait, I have two more. Okay, it says, write a program that begins by reading the denomination of a dollar bill, meaning how many, what size is the dollar bill? How big is it? Is it a 1, a 5, a 10, or 20? Then your program should display the name of the person whose face is on the front. Display an error message if no such note exists. Okay, so let's just start at the very beginning. It says write a program that reads in the denomination of a dollar bill. So we have to think, do we want to read this in as a string or as an integer? So if I go bill equals, we can do this as an integer. Actually, we can just do this. Yeah, let's do this as an integer. So input for bill size. Okay. Again, I need to save it. So let's go bill exercise. So if I run this, right, it says enter bill size. I enter a 5. Nothing happens. I didn't tell it to do anything, but it works. Okay, so it says print the name of the person whose face is on the front. So if bill, if it's a $1 bill, right, whose face is on the front of a $1 bill, print Washington. Right, if it's not that, then elif bill, if it's a 5, whose face is on the 5. Go print Lincoln. If it's not one of those, check if it's a 10. Print Hamilton. If it's not one of those, check if it's a 20. Print Jackson. And I have a table that I'm looking up with these, right? I don't just know these off the top of my head. If you didn't know this, you'd probably look it up on a table, like just Google, Google the information you need to know for it. So if it's not a 20, check if it's a 50. If it's a 50, print Grant. Finally, if it's a 100, print Franklin. Okay, so it does each of those, but then it also says display an error message if no such note exists. So it's not, if it's not a 1, 5, 10, 20, 50, 100, else print that note doesn't exist. Actually, elif bill equals 2, print Jefferson is on a $2 bill. Okay, so it's going to go through, it's going to check if it's a 1, do this, if it's a 2, do this, and it's going to print each of these out. So if I go here, let's test it out. So if I enter a 50, I get the name. Oops, I don't want that. If I enter, say I enter like a 45, who's on the $45 note? That's not an actual dollar bill, because this note doesn't exist. And we got that working. Okay. My final example is a bit more interesting. We have a chessboard or a checkerboard, and they're labeled with positions. So this is A, this is column A, this is row 1. So if somebody tells me position C5, I go to column C and up to square number 5. I want to write a program that will tell me if the square is black or white. And I don't want to have to check if it's A1 black, if it's B2 black. I don't want to check each of those. So I'm going to try to be a little bit smarter about this. Okay. So what can I notice about this? Notice how it goes black, white, black, white, black, white, black, white, right? So these ones are the same. If it's an A1, 3, 5, and 7 are black. If it's a C, C1, 3, 5, 7 are black. It's an E. So really, if let's say column equals input, enter column, and row equals enter row. And actually the row I want as a number. That's going to be an integer. So I make that into an int. Okay, so basically we notice that columns A, C, E, and G are the same, right? They go black, white, black, white, black, white, right? They're the same for A, C, E, and G. So let's just consider the two conditions. If call for column equals A, or, right, because in each of these cases, we're going to be doing the same thing. Right, so if it's A, C, E, or G, we can do the following. So how do we know if it's one of these columns? Now we only need to look at the first column because we know the other ones are the same. How do we know if it's black or white? So let's look at the numbers, right? So it's black if it's 1, 3, 5, 7. What do those numbers have in common? Well, we know that they're all odd. So if it's odd, then we can check, or then we know it's black. So if it's odd, so if row, if it's odd, actually, let's say if it's even, it's white, otherwise it's black. So if row remainder, when I divide by 2, right, remember this is the remainder, so if it's the remainder when I divide by 2 is 0, that's the same as being divisible by 2, meaning it's even. If it's even, print white. Else, So if it's not even, then it has to be odd. Print black. Okay. So now this should work for each of these columns. So here, if I do A and then 5, that gives me black. If I run it again, and do, say, like we do like E8, E8, I get white, which is what I expect, right? I see this in the picture. I have E column row 8 is white because 8 is even. Okay, so back to the other cases, right? So what have we not done yet? We've checked A, C, E, or G. Now notice that B, D, F, and H columns have the same pattern, right? They go white, black, white, black, white, black, white, black. So these are all of the columns. They're all the same, but these are all of the columns that we didn't already check. So if it's not one of those first columns, we know what to do. It's going to be one of these other ones. If it wasn't A, C, E, or G, then it has to be B, D, F, or H. So this is the case when we're looking at these other columns. And here it just swaps, right? If it's even, then it's going to be black. If the row is even, it's going to be black. If it's odd, it's going to be white. So actually, I can just copy paste this. I just need to swap the black and the white, right? If it's even now, it's going to be black. Otherwise, it's going to be white. So I can run this, and let's have an example. So let's just pick F6. F6. Now we expect that this should be black. Okay, that works. Let's try another one. Let's try B5. No, let's try B1. Okay, B1 is white. So it looks like, so far, like the program is working. And this is how I would do it, just like this. Right, so we check which column. If it's A, C, E, or G, then we do this. Otherwise, it's going to be the other ones, so we do this. In these columns, if it's an even number, this is how we check if a number is even. If it's an even number, then it's white, otherwise odd numbers are black. In the other columns, it's the other way around. Okay, so here's a question for you. Can you write a program that will read in a number and check if it is a leap year? I'll type it out for you in this separately. But write a program that will check if a year is a leap year. So right here, we want to check. So write a program that will read in a year from the user. Check, see if it is a leap year, print leap year. Otherwise, print not a leap year. Okay, so the rules for whether or not a year is a leap year are the following. Where'd it go? There we go. Any year that is divisible by 400 is a leap year. Of the remaining years, any year that is divisible by 100 is not a leap year. After that, any year that is not divisible by 4 is a leap year. Otherwise, all the other years are not leap years. Okay, so give that one a try. Here's another one that you can try. This one might be a little bit easier. We'll determine letter grade from percent grade. So what this means is that if you get like an 85, you get a B. So I want to give it a number that will read in a grade and determine the letter grade. And here's the rules for how that will work, right? If we know that, so we get an A if it's bigger than 90. We get a B if it's in between an 80 and an 89, or it's in between an 80 and 90. We get a C if it's in between 70 and 80. We get a D between 60 and 70. And we get an F if it's less than 60. Right, so if the grade is bigger than a 90, we get an A. So we just print that out. Okay, so these other problems, I'll send them separately also. I'll see you guys later.